visible to everyone? PPT?
Yes, ma'am.
Okay. So, anyways, we have completed two modules, the first and second. In the first chapter module, we discussed introduction about the crypto system, where we studied the classic crypto algorithms, right? And in the next chapter, we have gone through the hash function, how it is used in crypto system and uses of it, and other applications also we saw in the second module. Now, third module is all about the random numbers, or you can say random generation. Let's start with that. See, if you are not able to follow anything, please, you can ask me the doubts during the class or after the class, anytime, okay? So, this module 3 consists of two chapters. The chapter 1 that regarding random number generation. Okay, you can see I have listed the points here, like providing freshness about the random numbers, fundamentals of entity authentication, like how authentication is provided, that we are going to study, and also passwords, how the passwords are need to be generated or how it is used. All that we are going to study in the random number generation. And in chapter 2, we are going to study the cryptographic protocols. So the protocols used in the crypto system, from the basics to protocols that is used in cryptography algorithms, that we will study in this cryptographic protocols. Okay, and you can see at the end, we also going to study authentication and key establishment protocols. See, key, if you follow symmetric key, then the key need to be shared between both the parties who are involved in the communication, right? So how it is established, that those protocols also we are going to study in the second chapter under module 3. Okay, we'll start from the first chapter, random number generation. So before starting this providing freshness, we'll see the basics of random number. So you all know what is random number, right? Yes, the randomly generated sequence, right? So where the particular pattern is not followed to generate the numbers. So those numbers are random numbers. If you consider this example, okay, see, I have mentioned the range from 1 to 100. If I ask you to generate the random numbers, see, for first attempt, consider I got 42 as a random number. The range I have specified here is 1 to 100, right? The number that is generated here is 2. In the next case, for the same range, 1 to 100, if you ask to generate a random number, it will not be the 42 as the output. It may be some other number which lies between 1 to 100. So that means for whenever you ask to generate the random numbers, the number will not be the same, right? So the numbers are randomly generated. You have random function in Excel when you work in Excel sheet, as well as in programming language, right? And you have studied the application of random numbers maybe in Python as well as in Java, right? And also where in which lab? That is CN lab. There you studied leaky bucket, right? Where to simulate the trials, different trials for different seconds. I mean, to simulate for the number of seconds, you generated the random number of packets, right? There you have used random number function in Java program, isn't it? So since you know this, the basics of it, we'll move to the actual concept, like in cryptography, why the random numbers are used. Okay, so you can see in this figure, in this diagram, the data is considered here. On this data, encryption algorithm is applied. This may be any algorithm, encryption algorithm. That may be the symmetric algorithm or asymmetric algorithm. On the data, we apply the algorithm, okay, to generate the cipher text, whatever text present here, this we call it as ciphertext, right? So to generate this ciphertext, we make use of a key for this algorithm, right? Uh, so now the question is, what is this key actually? So whatever the key that I'm considering here will be the random number. Okay, so whatever presented in this diagram, I've just listed here. Okay, the first thing is what? The data that need to be protected. That means the data that is involved in the communication, which is the next element in this encryption, that is encryption algorithm. So whatever algorithm that we use for the encryption, that is mentioned here. So as I said, it may be, as I have mentioned in the bracket here, this is public information. So we already know what are all the encryptions algorithm are in use in the market, right? So that is one thing. And the next is very important. This is encryption key, where the random numbers comes into picture. Okay. And as you know, this key should be kept as secret for the symmetric cryptography. Whereas in the asymmetric, if you use a public key algorithm, obviously there also we make use of private key and public key, where public key will be known to the public, but private key will remain secret, right? So whatever the key that we use for the encryption algorithm should be a secret one. It should not be revealed to other person, or else what happens? Attacker will get a chance to hack this data, right? So now the question is, whatever the data that we want to protect, or you can say to maintain the secrecy of the data, we use a encryption key, and that should be kept as a secret. Okay. Now, if encryption key is not secret, if any attacker, if he predicted the encryption key, then what happens? Obviously, the hacker will attack that system, and our data will no more protected, isn't it? So I have listed few more examples here. You can see where the random keys or the numbers are used. You can see in the web browser, for each and every session, a session key is used. Okay, and this is where we make use of random numbers. Fine. And also, just now we discussed, that is encryption keys in different algorithms. One more usage of random numbers. And also in lottery draw, the lucky one we will pick, right? Out of n number of ticket buyers, we will draw one lucky, what to say, participant who will win the lottery. During in such examples also, the random numbers are used. Am I clear to everyone? Are you all able to follow this? Please don't drop the message in chat box. Please unmute your mic and tell me. Is it clear to everyone?
Yes, ma'am.
Okay. So now you're well aware of random numbers. I mean, why do we need random numbers in crypto algorithms, right? So we'll move on to the next part here. What actual meaning of random? If you search for the meaning of random, it is happening without method or conscious decision. Or there is one more meaning is, it is unexpected number. Okay. Now the question is, whatever the computer, whatever the numbers that are generated in using computers are really random values. Okay, that is one question need to be answered. We'll see the answer in next slide. In further slides. Okay, and whatever random numbers that we generate or use in the cryptography are really random. If it is really random, how the randomness is attained? So all these questions are answered in the further slide. So do remember, random numbers, without random numbers, the crypto system is of no, crypto algorithms is of no use. Why? Because if the numbers are known to the attacker, or the pattern using which the random numbers are generated If it is known to the attacker, obviously he will hack the system, and whatever the data that we are supposed to protect it is no more safe. Okay, so that is one thing. And I want you to see this video. You will understand. One second. You will understand. Please watch this video carefully. I mean, do listen all the explanation given there, because if you look at the video, you will come to know what actually true random is and pseudo random. Okay, you will understand how the random and randomness is attained. Okay, so one second. Okay. Is my screen visible to you?
Yes, ma'am.
Just listen to this. You watch this video and listen to the explanation that is given here. Okay? Is it audible? Yes?
No, ma'am. Slight less.
Yes, Salmanta. One second, I'll play the video now.
When we observe the physical world, we find random
Is it audible now?
fluctuations.
Yes, ma'am.
Okay.
When we observe the physical world, we find random fluctuations everywhere. We can generate truly random numbers by measuring random fluctuations known as noise. When we measure this noise, known as sampling, we can obtain numbers. For example, if we measure the electric current of TV static over time, we will generate a truly random sequence. We can visualize this random sequence by drawing a path that changes direction according to each number. known as a random walk. Notice the lack of pattern at all scales. At each point in the sequence, the next move is always unpredictable. Random processes are said to be non-deterministic since they are impossible to determine in advance. Machines, on the other hand, are deterministic. Their operation is predictable and repeatable. In 1946, John von Neumann was involved in running computations for the military, specifically involved in the design of the hydrogen bomb. Using a computer called the ENIAC, he planned to repeatedly calculate approximations of the processes involved in nuclear fission. However, this required quick access to randomly generated numbers that could be repeated if needed. However, the ENIAC had very limited internal memory. Storing long random sequences was not possible. So, Neumann developed an algorithm to mechanically simulate the scrambling aspect of randomness as follows. First, select a truly random number called the seed. This number can come from the measurement of noise or the current time in milliseconds. Next, this seed is provided as input to a simple calculation. Multiply the seed by itself and then output the middle of this result. Then you use this output as the next seed and repeat the process as many times as needed. This is known as the middle squares method and is just the first in a long line of pseudo-random number generators. The randomness of the sequence is dependent on the randomness of the initial seed only. Same seed, same sequence. So what are the differences between a randomly generated versus pseudo-randomly generated sequence? Let's represent each sequence as a random walk. They seem similar until we speed things up. The pseudo-random sequence must eventually repeat. This occurs when the algorithm reaches a seed it has previously used and the cycle repeats. The length before a pseudo-random sequence repeats is called the period. The period is strictly limited by the length of the initial seed. For example, if we use a 2-digit seed, then an algorithm can produce at most 100 numbers before reusing a seed and repeating the cycle. A 3-digit seed can expand past 1,000 numbers before repeating its cycle, and a 4-digit seed can expand past 10,000 numbers before repeating. Though if we use a seed large enough, the sequence can expand into trillions and trillions of digits before repeating. Though the key difference is important. When you generate numbers pseudo-randomly, there are many sequences which cannot occur. For example, if Alice generates a truly random sequence of 20 shifts, it's equivalent to a uniform selection from the stack of all possible sequences of shifts. This stack contains 26 to the power 20 pages, which is astronomical in size. If we stood at the bottom and shined a light upwards, a person at the top would not see the light for around 200 million years. Compare this to Alice generating a 20-digit pseudo-random sequence using a 4-digit random seed. Now this is equivalent to a uniform selection from 10,000 possible initial seeds, meaning she can only generate 10,000 different sequences, which is a vanishingly small fraction of all possible sequences. When we move from random to pseudo-random shifts, we shrink the key space into a much smaller seed space. So, for a pseudo-random sequence to be indistinguishable from a randomly generated sequence, it must be impractical for a computer to try all seeds and look for a match. This leads to an important distinction in computer science between what is possible versus what is possible in a reasonable amount of time. We use the same logic when we buy a bike lock. We know that anybody can simply try all possible combinations until they find a match and it opens. But it would take them days to do so. So for 8 hours, we assume it's practically safe. With pseudo-random generators, the security increases as the length of the seed increases. If the most powerful computer would take hundreds of years to run through all seeds, then we safely can assume it's practically secure instead of perfectly secure. As computers get faster, the seed size must increase accordingly. Pseudo-randomness frees Alice and Bob from having to share their entire random shift sequence in advance. Instead, they share a relatively short random seed and expand it into the same random-looking sequence when needed. But what happens if they can never meet to share this random seed?
Okay, that is a video. One second. So this video is all about to say what is true random and what is pseudo random. You might have understand how the true random numbers are generated, right? So true random numbers are generated by following the physical phenomena that happens in the surrounding that is we are present here. See, you have seen in the video what the flowing of water or the clock ticks and all that, right? So those are the physical phenomena which helps in generating true random numbers. Okay. So if I say true random numbers, what it means? The number that is generated should not be predicted by anyone. So such random numbers should be used in the encryption algorithms, or you can say crypto algorithms. Pseudo-random means what? You have seen in that video, a seed is used, right? The seed is what? The initial value that is fed to the random generator machine. So based on the seed value, the random numbers are generated. Okay, you have seen in the video when you give a seed value as two digits, the possible random numbers generated are 100, right? So after completing 100 random numbers, it will continue the cycle. That means what? After 100 numbers, again the seed value will be repeated and all other number is also repeated. So one full set we call it as a period. Okay, when the random numbers start repeating, that we call it as a cycle. Okay, so the thing you should know here is true random number and pseudo random number. Is this clear to everyone? What is true random number and pseudo random number? Please reply.
Yes, ma'am.
Okay, then we'll move to the next part. I hope the slide is visible now. Yes? Okay. Here in this diagram you can see just taken an image to see if the truly generated random numbers, the numbers which follows the true random numbers are required for the secrecy and privacy. Then our data is protected. If RNG here in this diagram, RNG stands for random number generator. One second. Random number generator. So if we use the machine which generates the random number is weak, then you can predict the random number that we are going to, that will be in use. Okay, so then the possible attacks are can happen on the data that you want to protect. Okay, so let's come to the actual syllabus here. So till now you understood what is random number, right? So looking at that video, you can see the cryptographic algorithms that are in use can't function securely without randomness. That you have understood by now, right? So randomness is nothing but the random numbers generated should be unpredictable and it should have a uncertainty. Okay, that is all about the random number and randomness. So to generate this randomness, two approaches are followed. The first one is non-deterministic generation and the second approach is deterministic generation. We'll see one by one. First one is non-deterministic generation. See, this non-deterministic generation deals with the physical phenomena. By following physical phenomena, whatever the numbers are generated, those we call it as a true random numbers. And true random numbers can be generated by following non-deterministic generation method. Okay, so I have listed here as this non-deterministic generation relies on unpredictable sources in the physical world. Okay, so whatever activities that happens in the physical world, those you can call it as a physical phenomena. Based on physical phenomena, the numbers which are generated are called as random numbers, and it will have a true randomness and it is hard to control and replicate those numbers. Okay, so what is deterministic generation? The deterministic generation is used to generate the true random numbers. Okay, and these numbers are generated by following the physical phenomena that happens in the physical world. Okay, so what is the source to generate true random numbers? That is nothing but the physical phenomena that happens in the physical world. Since it is difficult to predict, so you can't replicate those numbers. So that is one advantage with respect to non-deterministic generation. This non-deterministic generation can be classified as hardware and software method. So using these two methods, we can generate the true random numbers. We'll see one by one. Let's consider the first one, that is hardware-based non-deterministic generator. So in this method, the physical phenomena is used to generate the random numbers. Okay, and with this, you need a specialist hardware. See, to generate, whatever the physical phenomena happens in the physical world, to detect that, you need a hardware. So that's why the name given for this method as hardware-based non-deterministic generator. So you need a specialist hardware, and this provides a true randomness. So please do remember, this is very important topic and it is easy to follow as well. Okay, the physical phenomena helps in generating true random numbers. Okay, and this is based on the hardware-based generator, a specialist hardware is required. The specialist hardware is nothing but it may be the selection of resistor, capacitor, or flip-flop, or AND gates, NOR gates, those kind of hardware. As a combination of all that, which may lead to a device or a hardware. So such hardware is used to detect the random numbers that is generated with respect to the physical phenomena that happens in the physical world. Okay, let's see few of the examples physical phenomena. Here, measurement of the time intervals involved in the radioactive decay of a nuclear atom. So this time interval is not, it doesn't follow a regular pattern. So this is one of the source to generate the random numbers. Another one is semiconductor thermal noise, which is generated by the thermal motion of electrons. So this is also one more source to generate random numbers. And third example here, instability measurement of free-running oscillators. And the next one, white noise emitted by electrical appliances. Even that is also treated as true random numbers. And the last one here listed, quantum measurement of single photons reflected into a mirror. So just few examples are listed here. there are many more physical phenomena which helps in generating the random numbers, and they are true in nature. Okay, I hope this is clear to everyone. Yes, is it clear to everyone? Please do reply. Yes.
Yes, ma'am.
Okay. The next one, the disadvantage. So what is the disadvantage with respect to this hardware-based non-deterministic generator? So since here special hardware is involved to detect the random numbers with respect to the physical phenomena, it is expensive. Okay, that is one disadvantage. And one more is actually the randomly generated output is produced too slow. Okay, in the video you might have seen how the random numbers are generated with respect to the physical phenomena, right? So it is a bit slow in generating the random numbers. The next method is software-based non-deterministic generator. See here, as name says, what random numbers are generated based on the software. Okay, so just understand this. Rely on the randomness of physical phenomena detectable by the hardware contained in a computing device. So this is the software-based non-deterministic generator. We'll see the example, then you will understand what the statement says. Okay? Capture of keystroke timing. So when you type or when you work in a system, if you enter the data through your keys, okay, so that is not in a regular pattern, right? So that is a source of true random numbers here. The next example, outputs from a system clock, the clock that is used in the computer system or laptop, wherever. So that is output is also considered as a true random number. And the third one is hard drive seek time. So when the hard drive, when the system runs, to fetch the data, the data is stored in the hard drive. To fetch it, obviously, the seek activity happens. The time with respect to that is also true source of true random numbers. The next one is capturing time between interrupts. Okay, so see when you work in the system, obviously, what consider you're working in what PPT, and at the background you're running some music. Okay, so here you're working in the PPT, you're inserting few diagrams, you're adding some content here, making the format and all. Okay, and at the background when you are playing some music, consider the currently running music is not you didn't like that music, so you want to change it, right? Okay, what you will do, you will go back to the particular YouTube or any music channel and you will change it, right? So these kind of interrupt that happens in the system are not random in nature. Okay, so this is one more. So such pattern or such methods are used to generate the true random numbers. And the last one is mouse movement. So when you use the system, obviously so it depends on the user, how frequently the mouse will be used, right? So this is also one more source for the to generate true random numbers. So that is, and last one is computation based on the network statistics. Even this is also considered a source to generate random numbers. Okay, so let's see the advantages with respect to this method. Obviously, it is cheaper one compared to the hardware because hardware is not involved here, and it is faster and easier to implement compared to the hardware-based method. Disadvantages: it, it has lower quality and easier for an attacker to access or compromise. So these are the advantages and disadvantages. So as a whole, with respect to non-deterministic generator, we faces two problems. The first one is it is expensive to implement. It is expensive to implement. That is first one. And the next one is, see, there may be some cases where you need to use two identical strings in two different places. See, if this is our requirement, then we are not able to use this non-deterministic generator. Why? Because every time the number that is generated will be a unique one. It will not be the same. That's why it is impossible to use this non-deterministic generator method in such cases. Okay, so that is all about non-deterministic generator. The next part is deterministic generators. This we'll see in the next class. Okay. One second. Before that, so I just want you to see this example. See this. I've taken random website. So here in this example, you can see I want to generate 100 random numbers. 100 random integers between the range 1 and 100. Okay. Is the screen visible to everyone?
Yes, ma'am.
Okay. So I want to generate this 100 random integers. Okay, and I want that to be displayed in a column wise, and even that should be 5. Okay. So let's see what are the numbers generated here. You can see 100 random numbers here, right? Yes. Starting with here it is 84, and you can see the format, whatever format I've given, it is displayed in the same format, right? So 5 columns are there. If you count it, there are 100 numbers. So this is the first trial I'm using. Okay. You just see here the beginning number is 84 and the last number is 57. Okay. So let's consider another one. Okay. So the same range I'll give. The format is also same. The next time. So you can see here before it was 84, right? The last number. And here it was some 57, I guess. Now it is changed, right? So this way, each and every time, whenever you generate the random numbers, it will be a different one. Okay. So now the question is, as I listed in the initial slide, random numbers that are generated in the system, are they truly random in nature? Yes? No. Why? Because this whatever output that is generated using the system are pseudo-random. They are not truly in random in nature. Why? Because you may have this question because here they may in the video you have seen what happens after one complete period, again the number will start repeating, right? So the same case happens in the system also. So to get a truly random numbers is not possible in the system. See, if seed value is less, I mean the number of digits that we feed to the system, I mean where the random numbers are generated, is when the number of digit is less, then the number of random numbers generated is also less. So it follows a pattern to give the random numbers. See, for the machine, in the video you have seen, based on the seed value, the random numbers are generated, right? So it is very important to choose the seed value so that you should have a long run of random numbers. And there is one more example. Consider this. Huh. consider this. See, this is a, what to say, uh, so this is a wheel. If you spin it, so each time it will stop somewhere, right? See, at first trial, see at this show triggers. Here I can see this danger symbol. Let me run it again. So I got the different ones here, right? Next time, again, I got the different one. How many symbols are there in the wheel? Six symbols are there, right? So here also the random numbers are used to generate the spin wheel. Okay. So in such cases also random numbers are used. That is what I wanted to say. And here you may have a question like what are the different generators used, right? So I will take the deterministic generator in detail in the next class. But these are the few examples you can see in this tab. So the examples with respect to non-deterministic, we already discussed in the slide. But whatever the examples that I have listed here, I mean that is there in this tab, are with respect to the deterministic generator. That means the output of this deterministic generator will be pseudo random. So I just showed the what 100 random numbers which are generated, right? So such output can be generated using any one of this method that is listed here. It may be middle square method, Lemma generator, LCD, or many more are there. Okay, based on this, based on the what application will decide which algorithm to be used or which. You can ask me the question. Any doubt till now?